are talking about dilations. So a dilation is a transformation that produces an image that is the same shape as the original, but a different size. So instead of being congruent, it is now similar to the original. Dilations are centered around the origin, 0, 0, unless otherwise stated. So for our purposes, it's always 0, 0. So we have something called scale factor. So scale factor is basically the ratio of the image length to the pre-image length. So we always think of it as how we're going to change the original is our scale factor. So if we want to think of it in terms of new and old, it's the new over the old. That's how we get it. So if the scale factor is greater than 1, the figure becomes larger. And if it's between 0 and 1, meaning a fraction or a decimal, it's smaller than the original. So our rule, we can use arrow notation. F is the scale factor. So whatever we put here, that's really what we're multiplying the x and the y by. So it's really the easiest one of the transformations that we're doing. So if the scale factor was 3, we would write the rule as 3x, 3y, and we would multiply the x by 3 and the y by 3. Okay, so it's honestly much easier to not even graph it. All we have to do is to multiply. So if we have these original vertices, so these are the pre-image, and we want to know what the vertices of the image are with a scale factor of 4. So we're going to say a prime, b prime, c prime, and just multiply everything by 4. So we have 0, 8, we have 16, 16, and we have negative 4, 16. Okay, so when we are graphing, just like before, you always have to have both the pre-image and the image. So if they don't graph the pre-image for you, you must graph it. Okay, so we're going to start with negative 2, 4 is the P, 4, 4, Q, and R is 4, negative 2. Connect your dots and then follow the directions. Okay, so they're saying it's dilated by a scale factor of 1/2. So I'm going to write out my new coordinates, P prime, Q prime, R prime, and multiply by 1/2. But what that really means, as long as there's a 1 on the top of that fraction, is you can divide by that bottom number. So negative 2 divided by 2 is negative 1. So we have negative 1, 2. We have 2, 2. Oh, I messed this up. I didn't see this. This is a quadrilateral. It's negative 4, negative 4, which is here. So this is our quadrilateral. This line is not needed, so it's this shape that we're using. This is the shape. Okay, and then this is S. All right, so getting back to this, so R prime is 2, negative 1, and S prime is negative 2, negative 2. So then we're going to graph these points and make sure we label it. And when we connect the dots, we will see that the new shape, the image, is half the size of the pre-image because we multiplied by 1/2. Now, we know it's similar. It's always similar. But it says to compare the ratio of the lengths. So the easiest length to pick would be this one or this one because we can count these up. So we always put the original on the top. So, sorry, the original goes on the bottom. So it is new over old. And if I'm going to, I can pick this side or I can pick this side. Let's pick this side. So we'll do PQ, but it will be the same for all sides that you choose. So PQ and P prime, Q prime. Okay. So PQ, I'm just going to count it up, is 1, 2, 3, 4, 5, 6 units. and P prime Q prime is 1, 2, 3 units. So then the 3 goes on the top because that's the new one. So 3, 6 simplifies to 1/2. So all of the lengths ratios will be 1/2 because we multiplied by 1/2. It's half the size of the original. And what do you notice about the angle measurements? Here's an important question. So the angles stay the same. This is a right angle and this is a right angle. The angles stay the same. It's the sides that get bigger in proportionate. It's like when you open up your phone and go like this, all of the angles stay the same measure. So what do you notice about angle measurements of the two figure? They are the same. So the angles are congruent. It's the sides that change the side length, whether they become bigger or smaller. Okay, so if the scale factor is 5/2, how would we write that general rule? So we're going to write it with arrow notation. So 5/2x, 5/2y. And is this an enlargement or a reduction? Well, it is a fraction, but if I turn this fraction into a mixed number, it's 2.5, which is bigger than 1. So this is an enlargement. Okay, and then if they give you a picture, how do we find the scale factor? We've already done this, but let's just do this one just to be clear. So on this, all of the side lengths are diagonal. However, I can use this side length and this side length. And I have to look to see what's my old, what's my new. So the larger one is the original, the smaller one is the new. So if I'm going to count up this measurement, I have 1, 2, 3, 4. And I'm going to count it, this measurement, 1, 2, 3, 4, 5, 6. So that would make this 12. So 4/12 simplifies to 1/3. So that means that it's a reduction, and the new one is 1/3 of the size of the original one. But don't forget, the angles are congruent. It's the sides that are the third of the side. And if we were going to write that with arrow notation, it would be 1/3 x, 1/3 y.